In this chapter, we're going to look at a concept called standard form. Now, standard form means to express numbers this way: 10 raised to the power 5. So this reminds us of indices. We're going to look at it in details in the future. So when I have a number like 100,000, 100,000 means 10 times 10 times 10. It has 1, 2, 3, 4, 5 zeros. Then times 10 times 10. So when you're multiplying a number, for example, 2 times 2, a number by itself, you can say it's same thing as 2 raised to the power 2. So 10 times itself 5 times will be 10 raised to the power 5. So this is the same thing. Instead of expressing it, bringing out all the tens this way, this is the same thing as counting the number of zeros: 1, 2, 3, 4, 5, and saying 10 raised to the power 5. Therefore, when you have 100, 100 will be 10 raised to the power, the number of zeros, 1, 2. 1000 is 10 raised to the power 3. Okay, now let's look at problems involving standard form. Express the following numbers in standard form. We have 730, 9,000, 5,246, 175,000, 3,650,000, then 480 million. Also to express these numbers in standard form. Okay, so to express in standard form, this, let's assume this 730 was 700. We'll just count the number of zeros. But the important thing is to make the number a unit. By unit, I mean less than 10. So 700 will be 7, which is now a unit, times number of zeros, which is 10 raised to the power 2. Okay, so 730 is same thing as 7. We can express it this way. It's same thing as 7.3 times 100. Okay, not forgetting the previous chapters, when you multiply this number by 100, we count, take the number of zeros, take out decimal points, the number of zeros to the right. So 7.3 times 100 will be 1 step, 2 step, which gives us 730. So to make it easier for us, just imagine we have a point here. We'll actually do count backwards: 1, 2. Okay, so that will give us 7.3 times number of times you counted to the back, 10 raised to the power 2. So this will be 1, 2, 3. Now it'll be 9 times 10 raised to the power 3. And this will be 1, 2, 3. Which is 5.246 times 10 raised to the power 3. So this will be 1, 2, 3, 4, 5. 1.75 times 10 raised to the power 5. When you're expressing this way, you leave the zeros out because they don't have any value when expressed this way. So I won't put 0, 0, 0 here. It's not necessary. So this will now be 1, 2, 3, 4, 5, 6. 3.65 times 10 raised to the power 6. This would be 1, 2, 3, 4, 5, 6, 7, 8. So after that's 4.8 times 10 raised to the power 8. So this is our answer. Okay, then the next thing we'll look at addition, subtraction, multiplication, and division of standard form. Now, to explain the concept, let's say we have 600 plus 500. What will be the answer? 1100. Now, let's express this in standard form. 600 will be 6 times 10 raised to the power 2. then plus 5 times 10 raised to the power 2, and our answer will now be 1, 2, 3. It will be 1.1 times 10 raised to the power 3. Now the concept of addition, just assume you are given this way, and I are told to find the answer now, which is this. The easiest way to solve it is add the units, which is this and this. You do 6 plus 5, because we have a plus here, will give us 11. Then since we have these two numbers common, since they are common, we'll just bring one out. So it will now be times 10 raised to the power 2. This should have been our answer, but this 11 is not in standard form. This 11 is same thing as the point to count it this way will be 1.1 times 10 raised to the power 1, then times 10 raised to the power 2. When you're multiplying indices of the same roots, for example, this is 10 and 10, what you simply do is to add the numbers above. So 1 plus 2 will give us 3. So our answer will be 1.1 times 10 raised to the power 3, which is the same thing as this. Okay? So whether you're adding or subtracting, the easiest thing to do is just do it for the constant, for these whole numbers in front. Okay? Now let's take examples. But before then, let's try this. Express 6 times 10 raised to the power 1 in standard form. 6 times 10 raised to the power 1. Imagine there is a dot just in front of this. Then count the number of the number here to the right. So when you count to the right, there's a 0 here, gives you 60. Or you can simply do 6 times 10, that's 60. Okay, 9.4 times 10 raised to the power 6, expressed in ordinary form. So it will be 9.4. From here, we'll now count 6 places to the right. From here, we'll have 1, 2, 3, 4, 5, 6, which will give us 9400000. By that I mean insert zeros here. So, which is 9.4 million. 9,400,000. Another example goes this way: 4 times 10 raised to the power 4 expressed in standard form. So this will be 4. Well, now there's a point here. We'll now count 1, 2, 3, 4. We'll put zeros here. That will be 40,000. Okay. So having looked at this example, let's now go to the addition and subtraction of standard forms. Okay, find the sum of 6.28 times 10 raised to the power 3 and 9.5 times 10 raised to the power 4. Find the sum. So the first thing to do is let's express these numbers. Let's make them uniform. So it will be 6.28 times 10 raised to the power 3. We're adding, don't forget, and it's 9.5 times 10 raised to the power 3, then times 10 raised to the power 1. When you're multiplying indices like this, don't forget, I told you before, you simply add. So 10 raised to the power 4 is the same thing as 10 raised to the power 3 times 10 raised to the power 1. Let me explain this further. 10 raised to the power 4 is the same thing as saying 10 times 10 times 10 times 10. So we can simply bring this together as 10 raised to the power 3. Then we'll now have it as times 10 or 10 raised to the power 1. Okay? So having expressed this way, let's further simplify it to be 6.28 times 10 raised to the power 3. Don't forget, we're trying to make this uniform. So this times this will now give us, we're adding 95 times 10 raised to the power 3. So they're now uniform. You can now simply do 6.28 plus 95. So factorize, we bring this 10 raised to the power 3 out. times 10 raised to the power 3. So we'll add this, it will give us 95 plus 6.28 will give us 101.28, then times 10 raised to the power 3. This should have been our final answer, but this is not in standard form. Don't forget, standard form is supposed to be units, so this can still go 2 places backward. So when you take it 2 places backward, it now becomes 1.0128 times 10 raised to the power 2, then times 10 raised to the power 3. Now these two are multiplying, we'll simply add, which will give us 1.0128 times 10 raised to the power 5. So this is our final answer. Okay, let's look at an example involving subtraction. So for this example says, find the value of 2.9 times 10 raised to the power 6 minus 3.8 times 10 raised to the power 5. What is the first step? We'll make the indices uniform. So it will be 2.9 times 10 times 10 raised to the power 5 minus 3.8 times 10 raised to the power 5. So when we multiply this, we'll have 29 times 10 raised to the power 5, then minus 3.8 times 10 raised to the power 5. So factorize. By factorization, I mean you bring out this 10 raised to the power 5 to one side, and the whole numbers to one side. So we'll have 29 minus 3.8. Then the factors, the common factors, this 10 raised to the power 5 now comes outside, 10 raised to the power 5. So when we subtract 29 from, when we solve this, we'll have it as 25.2 times 10 raised to the power 5. This should have been our final answer, but it's not in standard form. You can go one place to this side. So that will give us 2.52 times 10 raised to the power 5. When we now add these two together, the same thing as 10 raised to the power 1, it now gives us 2.52 times 10 raised to the power 6, which is our final answer. Okay, let's look at multiplication. It's basically the same thing. 6 times 10 raised to the power 9 times 8 times 10 raised to the power 2. So factorize again. 6 times 8 times 10 raised to the power 9, then times 10 raised to the power 2, or let's collect like terms. 6 times 8 gives us 48, and this times this will give us 10 raised to the power this plus this, which is 11. So we'll make this expressed in standard form, which is 4.8 times 10, then times 10 raised to the power 11. When we multiply this, we'll have 4.8 times 10 raised to the power 12. Okay, same thing goes for division. Let's look at division. 8 times 10 raised to the power 4 divided by 2 times 10 raised to the power minus 2. So to solve this, let's express the division properly. 8 times 10 raised to the power 4 divided by 2 times 10 raised to the power minus 2. Whenever you have indices like this dividing, like I told you before, if you're multiplying 10 times 10 raised to the power 3 times 10 raised to the power 2, you simply add the power. So we'll have 10 times 10 raised to the power 5. But when they are dividing, 10 raised to the power 3 divided by 10 raised to the power 2, you do the opposite, which is subtraction, and that will give us 3 minus 2, 1. That's 10 raised to the power 1. Let me explain this. 10 raised to the power 3 is 1000, 10 raised to the power 2 is 100. So when you cancel these two zeros, you have 10. So as I said, subtract. So for this now, they're dividing. So all we're supposed to do is subtract. So we'll have 8 over 2, then times 10 raised to the power 4 minus 2. Okay, so minus will give us plus, which is 8 over 2 times 10 raised to the power 6. So 8 divided by 2 will now give us 4. Then times 10 raised to the power 6, which is our final answer. Now click on Start Quiz and take all the questions